support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Susie.
And in studio we have with us Christian. And Christian, if somebody wanted to get a hold of us, what would they need to do?
Well, for math homework help, call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org, and or online at dothemathonline.net, and on social media, Facebook, Instagram, Twitter, and YouTube.
Now, you were just commenting that you do YouTube things, right?
Yes.
Do you do all of those things? Facebook, Instagram, Twitter, and YouTube, or just YouTube?
YouTube.
All right. Why don't you let everybody know where you go to school and what grade you're in?
Well, I go to school at Kristen McAuliffe Elementary, and I am in grade 6.
How's sixth grade going?
Interesting.
Well, that's a good way of saying it, right? Nothing too bad, nothing too good. It's interesting. Well, since it's interesting, what is one thing you would change, if you could, about sixth grade? Or about school in general?
Instead of having a 5-minute recess, have a 10-minute recess.
So extended recess.
Yes.
I would go in extended recess also myself.
Yes.
Now, you have been working on some math problems. All right, so what we're going to do is have you go on over to the board right now with Susie, and we're going to work on some of the ones that you have for homework right now.
All right.
So you're doing algebraic expressions. So what do you know about expressions right now? When somebody says you have to do an expression, what comes to mind?
Letters and trying to solve for x.
Okay, so you have a variable in there, right? Most
Yeah.
often it's x, but it could be any letter, right? All right, so here we go. Let's take a look at some of these that we have. So you're going to have to write an expression. And Susie's right there to help you out if you need some help.
All right.
All right? So the first one in your book is the sum. So you're going to need to know some vocabulary.
Yeah.
So when I say the sum, what do you know already?
It's addition.
It's addition. All right? So the sum of x and 9, how would you write that as an expression? So go ahead, grab a marker, and the sum of x and 9.
I would do this.
That's very good.
All right, let's go on to the next one.
All right.
6 more. So let's go ahead and we'll put this underneath the camera so that way if you need to look at it, you can. The sum, let's go with the difference. Number 3, 6 more than the difference of b and 5. So 6 more
I'm going to write it. Okay.
than the difference.
You can tackle it in
Of b
parts.
and 5.
Oh.
All right, so let's get the 9 plus x out of there. You're all through with that expression.
Okay. Good. So, do you know how to do 6 more than?
Well, at the end of the equation, you'd add on 6.
That's perfect. So put plus 6 there somewhere. Okay. And now, do you know how to do the difference of b and 5?
It would be b minus 5.
Good. Go ahead and write that first then. Okay. Now, when you're doing difference, it's important to get them in the order that it says. Like with the adding problem last time, it didn't matter if it was 9 plus x or x plus 9. But with difference, it does matter, and you did it correctly. Now, some people would do 5 plus 6 first. Do you know anything about that already?
Well, PEMDAS says to do addition before subtraction.
Well, PEMDAS says addition and subtraction are tied.
Oh, so you do the
in order.
beginning.
Yeah, you do them in order from left to right. So we would actually do this part first.
Yeah.
Okay?
All right, let's go on to the next one. Let's take a look at the next one we have on there. The sum of 15 and the product of 5 and V. So the sum of 15 and the product of 5 and V. So the product of 5 and V is in Victor.
I know what the product of 5 and V is, but I'm a little confused of sum of 15.
Okay, that's a good, very good question. Okay, the sum of, we have to have something and something, right? Okay, so this is the first something, and this is the second something. So you have plus here.
Oh.
Does that kind of make sense?
Yes.
Yeah, when you have, because you have some of, you have to have two things. So that was a
Yeah.
really good question.
Okay.
Okay, now can you finish it?
I think it's 15 plus 5 times V.
Okay, and then that's perfectly okay. Have you started leaving out the x?
Oh yeah, you put them together and it still makes it.
Yeah, so you can do it like this.
Multiplication.
And this isn't wrong, it's just sometimes we don't want you to think that it's 5 times x times v. So it says 5 times
Oh,
v. Does that make
yeah.
sense?
Yeah.
But you're in 6th grade, but once you get to 7th and 8th grade, we hardly ever write that. Except in,
We started doing it in 6th grade already.
did you? Good for you.
Well, good. Erase the board. You're on a roll. Let's get another one going.
Okay.
Number 5 on your homework page. The difference of 2 and the product of 3 and k.
Ooh.
The difference of 2 and the product of 3 and k.
Okay.
I bet you're already thinking.
Yeah.
Yeah, okay. It's kind of like the last one, isn't it? Okay.
So I would do 2 minus 3.
Good job.
All right. You ready for the next one?
Yes.
Here we go. Time for a little division.
Ooh.
12 divided by the sum of h and 2.
12 divided by the sum of h and 2. All right. Do I do it?
Yeah.
All right. Okay, 12 divided by the sum of, so it'd be addition. Oh, yeah. And 2.
Okay. We only have to do one more thing to make it correct.
Ooh.
12 divided by the sum of, do you already know?
Of what?
Okay,
Let me look.
so do you see how this is stuck together?
Yes.
So what could you do to make sure that we don't do 12 divided by h before we do h plus 2? Very good. And then, have you started writing it like this yet?
Yes, but not in. No, not that way.
Okay, so not in 6th grade. Okay,
No, not yet.
so this actually means division. The fraction
Yeah.
bar means division. You already know that. Okay,
But it's just we haven't started.
but this is
yet.
correct. This is definitely correct. Okay? All right.
All right, you're on a roll. Let's take a look at some more vocabulary as we continue with the next problem. The quotient of m and 7.
The quotient of m and 7. Well, quotient is, so that'd be m divided by 7.
Okay, let me ask you something. Is this the same thing?
No.
Good. Excellent. Because with division and subtraction, you do have to keep them in the
Yeah.
order. Okay, very
Addition and
good.
multiplication are the same
Yeah.
either way.
You got it.
Here we go. On to the next one. Number 9, or number 8, I think we're on. 9 more than 2 multiplied by f.
Oh. All right.
9 more than 2 multiplied by f.
Okay, and then, yeah, no, you're right, because you would do multiplication first, so you don't have to have the parentheses, but you could also do it like this.
The multiplied got me there, so
Yeah.
I just instinctively.
Don't, there's nothing wrong with that, okay? I'm just showing you another way, okay?
All right, we'll do one more because we're not going to do all of them, but we'll do one more.
Okay.
All right?
All right.
So 6 minus the difference of x and 3.
Difference. Oh, okay.
6 minus the difference of x and 3.
6 minus the difference of x.
Okay, now, it said 6 minus the difference of. Now, when you see the difference of, that's kind of like parentheses. So you do have to do this.
Yeah.
Now, have you already learned what happens when you have this outside of parentheses?
You do the parentheses first, and then you do the 6 minus.
Yes, if you know what the x is. Yes, that's correct.
Right, once you know it, if that's
Yeah.
what you're going to be solving
Yeah.
for and things like that. Nicely done.
Okay. Good job.
We do have phone tutors available until 5:30 as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the
Good job.
News.
Okay, come over here.
Oh.
All right, today's Math in the News has to do with the past holiday season that was just here. So yesterday we talked a little bit about the New Year's ball that drops in Times Square and how long it takes to travel down that pole, how fast it travels and things like that. So let's take a look at the screen right here. So Christian or Terry, do you guys have any idea what that is?
Is it when the final dinner in the Bible?
No? Good guess though, because it kind of looks like that, right? A big gathering, you know, people eating and drinking and things like that. That is the first Christmas card.
Wow.
Oh, wow.
Yeah. So,
neat.
That's interesting.
since a lot of people have been sending out Christmas cards and things like that, Henry Cole lived in London, and he had a problem of having too many friends. Okay?
Good
So
problem.
during Christmas, he had so many letters that needed replies. In 1843, he commissioned an illustrator to design a card that would express his sentiments. So that way he could get the cards out to all of his friends easily. So chromolithography is what he used, a lengthy process that involves multiple layers of color and shading. Once the design was finished, thousands of copies could be made and mailed. Cole's acquaintances realized how efficient the card was and followed suit. The Christmas card was born. So that is the first Christmas card. So
That's very
the
interesting.
reason I brought that up is because obviously the past holiday season, but now we need to tie some mathematics to it.
Right.
So taking a look at the next graphic we have, card sales in the USA. So based on this, so if we see a graph like that, Christian, do you have an idea what that type of a graph is called?
It's a pie graph.
Pie graph, right? Okay, circle graph. And it's broken into different parts. And what you need to do is you need to be able to figure, so first of all, think about a circle. Do you know how many degrees are in a circle?
360.
360 degrees. So you need to have that knowledge in order to accurately produce a pie chart, a pie graph, okay? So we can take a look here, we can see that Christmas, that greenish area, is 61%. Wow. The next biggest is Valentine's Day at 25%, Mother's Day, Easter, Father's Day, and then other cards like birthday or something like that, any other types of holidays that would be coming up. But you can see that Christmas is by far the biggest one.
Yeah.
It more than doubles
Yeah.
the next one, which is Valentine's Day.
Valentine's Day is only about a quarter.
Right, so it's a quarter of the total, and Christmas is more than half. So we just want to talk a little bit about the degrees in the circle, and if you know how to use a protractor, then you can make a pie graph. And I'm sure in 6th grade you guys will be doing that at some point if you haven't done it already.
We haven't done it already, but we probably will do it.
I'm sure you will be doing it. All right. 636-4357 is the phone number. That is today's Math in the News. Are you ready, young man, to do some more work? Of course you are. That's why you're here. Now, In class, I know that you've been working, you were talking about you were doing some work with exponents.
Yes.
All right, so head on over to the board, and you and Susie are going to do a little bit with exponents right now. So first of all, Susie, let's put up let's go 3 to the 3rd power.
Oh.
And first of all, let's just talk about vocabulary, like what the different parts are, the numbers, what they mean, and the vocabulary for those numbers that are up there. All right, take it away.
Okay, so this number is called the base, okay? And this is the exponent, okay? Okay, and this whole thing is a power, okay? That make sense?
Yes.
Okay.
So now, do you know, Christian, what 3 to the 3rd power is?
Yes. Do you want me to write it down? All right. It would be 3 times 3 times 3.
Right, and can you evaluate it?
Well, so 3 times 3 would be 9, and then 9 times 3 would be 27.
Good. Go ahead and write that. What do you think that, what equal 27? Yeah. What do you think the most common wrong answer is?
Like how they write it or what they get?
What they get?
Well,
If somebody sees 3 to the 3rd power without it written out as 3 times 3 times 3, what do you think some people may put?
3 times 3.
Right.
Which would
9.
be what?
9.
Yeah.
Okay.
I get that answer all the time.
So let's try this one. Let's go 2 cubed. Do you know what cubed means?
Kind. No.
Well, that's why you're there with Susie. 2
Not
cubed.
really.
Do you want to know why it cubed means 3rd power?
Is
Well-
it because it's 3-dimensional?
Exactly. You have length, width, and height. So it is 3-dimensional. That's
Okay.
excellent. Okay.
So 6 cubed would be 6 to the 3rd power.
Right.
Okay.
Okay. So do you know what 2 cubed is?
It would be 2 times 2, which is 4, times 2, which is 8.
Good. And I really, really like it that you write this out. That shows that you know what it means.
Because what would a student possibly put if they saw a 2 to the 3rd power? What could they think automatically?
2 times 3, which
Right.
equals 6.
Right. See, and that's the whole reason why you need to understand that when you expand it like that in that form, it is 2 times 2 times 2.
Because
Yeah.
I used to do that. I would
Yeah,
put
my
2
students
times
don't
3.
like it, but I would make them write it out.
Well, especially
have
if
to
you
know
have
what it
something to
means.
a high exponent power.
Yeah.
All right, so have you worked in other things with exponents in class?
We've done it in like equations, so it'd be like 2 to the 4th power plus 3, and then in parentheses like 5 plus 2.
Have you multiplied with
2.
exponents? How about Susie
Yes.
go over a little bit of
Yes,
that with you right
I
now?
think we have. Yeah.
So what if I had 2 to the 3rd times, and I'm going to use the dot, okay, times 2 to the 4th.
Well, it would be 2 times 2, which equals 4, times 2, which equals 8, and then 2 to the 4th would be 2 times 2, which equals 4 again, times 2, which is 8, times 2, which is 16, and then it would be 16 times 8.
Go ahead and do that.
Well, is it okay if I write it
Yeah.
out like this?
You bet.
Sorry for my unneat handwriting.
It's hard to write neat on this board.
So it would be 128.
Good.
Oh, do I?
Yeah. Now, sometimes on tests, whoa, what did I do wrong? I used the wrong side, huh? Okay. Sometimes on tests, they have you simplify it without going that far. Now, so I'm going to write this like this. Or they'll ask you, if they say, write the answer as an exponent, as a power, I mean, what could this be?
2 to the 8, and 2 to the 7th.
Right. Yes. Okay. And even though it says multiplication, why didn't we do 3 times 4? Can you think about why we didn't do 3 times 4?
It's because 3 times 4 is an exponent, not just a normal base number.
Right. The bases, the 2's are being multiplied
Yeah.
together, not the exponents. So do you see a shortcut there?
Well, I guess you could do... Oh, you could do 3 plus 4, which equals 2, so you already know what your exponent is.
Yeah, equals 7. Yeah.
And then...
But it is better to write it out.
Yeah.
It's always better to write it out. But someday you're going to have problems like this.
I was going to say, let's give them some large exponents there and see why you don't want to write it all out.
Okay, see, I don't want to write that out. But what's the shortcut?
3 plus 4.
Okay, so you figure out what the exponent is on this one.
Oh, could I use the red
Yeah,
one?
you bet.
Well, 3 plus 1 is 4, so 54 plus 10 is 64. Wow, that is
Yes,
Big
2 to the
exponent.
64th. And we would not want to write that out.
Nope.
You
Write it
could, but
out
you
if-
could do that
yeah.
during the break, not right
Yeah.
now. Anyway, nicely done on the exponents right there. Hopefully that helps you out a little bit for when you get into multiplication with exponents in your regular classroom. For your great work right there, you've got yourself a couple of tickets to go see the Bakersfield Condors. So season is underway right now. Hopefully you get an opportunity to go see one of the Condor games soon. We'll be back with more right after this.
Hey, a little math in the real world again. We are happy to be out here in the nice sunshine and really interested in the things that go on around us here in Kern County. Some of which, of course, is in the oil fields, but most of which we see up and down the roads in the form of agriculture. We know that agriculture is a big industry here in Kern County, and we want to know a little bit more about that. We've had a chance to visit with people who pack grapes. We've had a chance to visit with people who take care of the plants, and now we want to come back to join Jeff Rasmussen and my friend Art Macias. Art, thanks for being here today.
Thank you.
Appreciate
Pleasure.
that. Jeff's got us some snacks, which is always wonderful to see. Art, tell us a little bit real quick about what you do and what your role is in the vineyards as we look around and see all these amazing grapes that we're all just salivating over.
Basically, what I do here is a vineyard manager, of course,
Okay.
and kind of oversee all the operation. Tractor drivers, PCAs, labor management,
Right.
and mainly it's labor management. It takes a lot of hours. It takes a lot of manpower to grow a vine, and not just basically grow it, but also to do all the stuff that we need to do: thinning, pruning it, packaging. And most of the time, most of our time, my time, is really concentrated on that. PCA, Jeff does always a good job. He takes care of his end. Then we have another gentleman, Hubert Basurto, and he does all the tractor driver and all that. And Neftali, and he runs all the labor. But of course, I oversee everything, but mainly taking care of the vines and looking at basically all the labor management, like I said, pruning, packaging, thinning.
Right,
you
and
know.
there's so much involved in that. We got a chance to talk a lot to Jeff last time about the individual things you can do either for a soil deficiency or for a pest that comes along, and there's obviously lots to do. And it's not just during harvest, right, Jeff? I
Right.
mean, there's things to do preventatively in the off season so that major problems don't happen in the future, right?
Right, and we work together. So I'm looking at the pest, the disease, and that's identified. But what we do is we work together, working with the labor to reduce the increase of conditions. So when Art prunes it and does a horticulture side of it, we get more air movement to the vine, more light, and so we work together trying to figure out how do we increase the crop without doing too much work, but we got to do what's best for the crop, and that's where we have different set of eyes that we're looking for specifically, but we come together and make the crop as best we can.
Right, and part of our discussion earlier was when you go to the grocery store, there's the fruit, right? And it must be super easy to grow because we see it all over the place, but it is not, and it is very time intensive. very labor intensive, and you got to make sure all those components work. Again, not just during harvest season, but during the off season, so they can prune up the vines and make sure they're ready for next year. Can we take a look at a couple things that have happened here recently? We know that your crew's already been through the vines once, and they picked it once.
Yes.
But as we go through, we can see there's still a lot of fruit on the vine, right? So when are they going to come back and pick again?
So what we do here is that we, like you said, we made a pass already through here.
Yeah.
And basically what we're looking for is, color, of course. This is a red variety,
Right.
so we're waiting for 100% color.
Right.
So we made a pass here about 2 weeks ago. I'm looking at coming back here probably at the end of this week.
Okay.
Also, it's also market driven too. So, if they're asking for reds, we got to go in there and pick them. If they're not asking, then we give it a little bit more time. But also at the end of the day, we got to do what's right for the fruit.
Yeah.
And so, we came in here, picked it already. As you can see a little bit of, like this area, there's hardly nothing, so some vines are picked a little bit heavier. Some areas are picked a little bit lighter. It just all depends. Jeff can explain it a little bit more, but, we all have different kind of soils in different areas.
Right.
So, and even the quality of it, and also the size. And if you look at it here, there's some little bit of different size here. It varies from side to side, right, Jeff?
Yes, and that's the beauty of it is, the toughest job I have right now is eating this stuff. I have to eat
So
it.
sweet.
Is it ready yet?
An
Again.
expert taste tester, you know exactly what's wrong with the fruit. Just, there's no better way than just figure out what does it taste like.
Yeah. So you got to make sure, hey, all right, let's go. Let's pick it. It's tasting good right now.
That's kind of a neat deal. Now we notice that all these plants as well are trimmed up off the ground. That's got to be part of the maintenance of what's going on here. But you got to be able to get some people in and out of here as well, right?
Yes.
And so not only in the off season do you have to trim, but you have to trim during the season as well, so that you get some sunlight on the fruit, but not too much. Boy, what a balance!
Yeah, and that is very important too. And I know that's where Jeff and I will work together. And air movement, getting air circulation through here, because in the middle of the summer, the humidity, hot summers here, it's very important to get air circulation through here, because we don't want to have any issues. But like you said, another thing is that we come in here and we cut canes. Usually we do it about maybe around June, Jeff. We'll come in here and do a little bit of hedging, really light. Enough to get our tractors going through here and making sure that we're not pulling anything. But right before harvest, we'll come in here and we'll also cut canes, as you can see a little bit here, a little bit higher. Easier to look at the fruit, easier for the people to work underneath here, but also to get some amount of ambient light in here and get some air movement, of course, but also the light helps the color of the berry.
Right.
Like as we're talking about, this is a perfect example right here, is when we developed the crop, we put this cordon right here, when we laid it down. And you can see this died, and so Art in the wintertime sees this and he'll lay down a new arm and hopefully replace this arm. And then Art and the crews that are trained, and our field workers, people don't understand, they're highly trained professionals that prune this. They're not just field workers. This is an art that you come in and see there's no fruit here, and we're trying to replace this arm right here to get more production. And so Art will come in. What happens is this canopy gets dense, and you can see these leaves are senescing in here. It's different from nutrient. This is just no chlorophyll. So what happens is these buds get no sunlight, and then therefore we have to open up and remove leaves. We'll pull leaves off to get more light in here. And that's what Art and I balance that discussion.
Exactly, and just to touch a little bit on that, what Jeff is saying is that, yeah, if you see these leaves are senescing, these leaves are not doing us any good. They're gone, they're done. So this is very important that we come in here at the right time and leaf it. Why? Because it's very important. Another again, going back to air circulation, getting the best quality of the fruit, open it up, but also to get some more ambient light in these spur positions, because like Jeff touched a little bit, getting sunlight in these buds is very important. If we, and I've done a little bit of research actually years ago, and I used to work at the research for Kearney. UC Davis, I used to work with a professor there. Okay. And actually I helped one of master students do an experiment, Jeff, on where we would come in here and cover these buds with a black cloth. Right. And then we would come in the afternoon and take ambient light readings. And then we would see, measurement. And then in the off season, what they would do is that they would cut the cane, take it back to the lab and then do a bud dissect.
Right.
So where we can see the bud fruitfulness for the following year.
Right.
Does it have an effect on that? Yes, it does.
Oh, yeah, definitely.
Very.
We want to know more about that. We got to go back to the studio and get some more math. I know that part, but when we come back, we'll learn a whole lot more about what exactly goes on in these vineyards that no one has a clue about. Maybe even eat some grapes along the way. Back to the studio.
All right, thanks for that, Scott, and thank you also to the Kern County Farm Bureau for helping out do the math. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, we have Christian, a 6th grade student from McAuliffe, correct? Mm-hmm. And how long have you been at McAuliffe?
Since kindergarten, so 7 years.
So you've been there the whole time. Wow. What do you think you're going to miss about McAuliffe? Because that's the only school you've ever been to.
Probably the playground, because there's a giant field that we can run around in.
Well, you like the giant field, huh? All right. Well, speaking of giant field, this is a giant game board. Have you ever seen one like this?
I see it on TV shows.
You've seen it on TV? Where have you seen this? Do you remember the show or what was going on?
It was, I think it was Cash Drop or something.
Okay.
Price is Right.
I haven't seen that, but The Price is Right is something we grew up on, and
Yeah.
it's still out there right now. And it's funny because one time when we brought out the Plinko board, I was asking the student if when they stayed home from sick, possibly from school, stay home, watch TV, and watch The Price is Right. They didn't know what I was talking about, but different generations.
I've been to the show twice.
Oh, you have?
Yes.
Were you
But I never
ever
got-
on, win
no,
anything?
I didn't get to go up.
All right. So were you there with Drew Carey or
No, many years ago.
with many
yeah,
years ago?
uh-huh.
All right. What
But
was
it's
that? Bob
fun.
Barker? Is
Bob
that-
Barker,
that's it?
yes. Mhm.
All right. So anyway, this is the Do the Math Plinko board, Christian. And you can see that we have a couple of different options down at the bottom. Do you think one of those would be easier to land in than another one?
Well, they usually bounce to the sides,
Right.
so the red and yellow would be easy to get to.
The red and yellow? Out of the two, red and yellow, which one do you think would come up more often?
Well, I like to drop from the right, so probably the yellow.
So you think the yellow. Do you think the red might have a better opportunity since there's twice as many reds?
Yes.
It could. But you're talking about if you drop it from here all the time, that you like to do, you think yellow will win.
Yeah.
Let's find out.
All right.
Take one, drop it, and let's see where it lands.
All right. I'm gonna drop it
You
right.
can drop it wherever you want. All right, come on over, we'll see. Ooh, nicely done. You've got yellow. There you go. All right, drop it again.
I'm gonna go for red.
You're gonna go for red? I thought you were gonna see if yellow came up most. So you're going for, you're a lucky boy. All right, you're 2 for 2.
Put him
We're
on
gonna
the
keep
toe.
going here. All right. All right, which one do you want to go for now, Hotshot? You can do a different one or one of the same you've already hit. Now, because it's not gonna land in here again because we have one down there, but you are 2 for 2 right now.
Oh,
All right.
I'm gonna go for red again.
Okay. Before you say you're going for red again, because there are 2 red, which one?
I'm gonna go for this one.
The one on the end?
Yes.
All right, let's see. Now that's funny because you would think that most kids would put it all the way at the far end to try to get that. 3 for 3. All right, we're going to keep this going until we're going to see how long you can go.
All right. I'm gonna go for the one green.
The one green. Now, before you do that, why are you dropping it right here?
Well, if I drop it closest to the green, there's more of a chance for it bouncing to other sides.
Let's find out what happens.
Put it right here.
There's your yellow hot shot. All right, you know what? You were on a roll. We'll give you one more try. That obviously is a bad token for you. Let's try a new one.
I'm gonna go for red again, the side.
You're going for the far side red. All right, last one. Let's see how you do. Ooh, oh.
Well, we got all the colors,
All right.
didn't we? Oh, no, we haven't gotten green yet.
I haven't gotten green. So how many different ones are there?
There are 2, 3, 4.
Well, how many different places can it land instead of colors?
6.
There are 6. Do you think you can drop one in every one?
Do you think I can do that?
Do you think you can do it? How many more tokens do you need?
1, 2, 3, 4. So I need
One
One
more.
more.
All right, let's see how you do.
okay. don't run in the same way.
Wow. He's really good at this.
Could bring him down. The Price is Right, huh?
Yeah.
Oh! Well, you made it halfway, son, right there. And for playing on today's game, you've got yourself some wonderful parting prizes. But anyway, we do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Branch Elementary, home of the Mustangs, and we're here to We're back at Branch Elementary, home of the Mustangs, and we're doing some order of operations with some 6th grade students. So we all know that PEMDAS, please end my day at school, the new saying that I found out today, right? So we'll do some more order of operations, all right? So you guys saw on the last problem how you could get 2 answers based on if you just went straight across or if you did the multiplication before the addition. So let's try another problem, all right? So, Caitlin, you're to my immediate right. Would you like exponents in this problem or not?
No.
No exponents? That's going to be difficult because I have exponents in every problem. So, would you like it to the 2nd power or to the 3rd power?
2nd power.
2nd power, by all means. Here we go. 2 squared, so 2 to the 2nd power, times, and then in parentheses, so open up a set of parentheses and put -9, close the parentheses, minus 9. So we have 2 squared times -9 minus 9. All right? So how do you think we should start?
I just started by doing 2 times 2.
Right. Right, because you've got parentheses, exponents, right? So you do the exponents first. So you've got 4. 4 times what?
-9.
4 times -9, and then minus 9. So we have 4 times -9. What's 4 times -9?
-36.
-36. All right, so you've got -36 minus 9. Now this is where some students get messed up. So you're at -6. So imagine you're underwater 36 feet. You're at -36, and you're going to go down 9 more. Where would you end up?
-45.
-45. That's okay. You added the 9 to 36?
Yeah.
Right. So that's the thing to think about, is when you're going negative, you're going farther down. So some people talk about owing somebody money, going from the top of a hill down or whatever, but just think about you're underwater 36 feet and you're going to go down 9 more, right? So logically you think, all right, it's going to be more than 36 feet down now. So that's why you add the 9 and you stay negative, all right? Let's try one more problem. 8 minus 5 times 4 squared, 4 to the 2nd power. All right, so Cameron, you got -72. How did you get -72?
So I started off with 4 squared and I converted that into 16, which I multiplied that by 5.
Okay.
And I got 80. And then I subtracted 8 minus 80 and I got -72.
Right. Now, is there a way where somebody could mess this up and get 48? How would somebody get 48 possibly? Take a look at what you've got here. You've got the 4 squared is 16, right? Okay, so it's good you guys are all getting -72.
So I think
They started from 8 minus 5, which got 3 times 4 squared.
Right, so what they did is they did everything correctly, but they did the subtraction first before taking care of.
The 4 squared.
Right, so that's what you need to do. So negative 72 is the correct answer. You guys getting the hang of order of operations? Good, so when we come back with the students at Branch Elementary, we'll do a little bit more, the next step up in the order of operations. And once again, big thanks to those students. Almost forgot out at Edwards with the jets flying by and things like that. You could always feel and hear what is going on around you. We do have phone tutors available until 5:30 this afternoon. We have Christian, a 6th grade student from McAuliffe, in studio. Right now, we'll go to the phones for another 6th grade student from McAuliffe. Jonathan, how are you today?
Good, thank you.
You have a math problem you want to work on?
Yes, I think Christian knows me, so
You want to say hi?
Hi.
Yeah,
Hi,
Christian.
Jonathan.
All right, so go ahead and read the problem, Jonathan, as soon as you're ready.
All right, so we have the same page, so it should be good.
Okay,
So,
so go ahead and read it.
So it says, let H represent Mark's height in inches. Suzanne is 7 inches shorter than Mark. Write an algebraic expression that represents Suzanne's height in inches.
This is perfect timing because if you were looking at the program earlier, Christian was doing some of these that were at the top of the page. This is one at the bottom, so this is perfect timing. So Christian, you go ahead and work on it right now
All right.
while Susie does it with Jonathan, and then we'll see how you guys did.
Okay. So, Jonathan, what would you think that we would start with?
Mark's height?
Okay, and we know that that's H, right?
Yes.
Okay, and so Hussein is 7 inches shorter than
Mark.
Mark. Okay, so do you think I should put 7 minus H or H minus 7?
8 minus 7?
You are right. And that's excellent. So,
Okay.
wait, I'm sorry. Goofed here. Oh, no. I was
gonna
thinking
say,
H is Hussein, but H is height.
Right, you're fine. So that's Mark's height, not Hussein, the other
Yeah.
boy's name. So what would happen, Jonathan, if Susie wrote it the opposite way?
It would be, I don't know how to say it, but it would be like wrong.
Yeah, it would be wrong because why would somebody do that possibly, though? Can you see why that might happen?
Yeah, because it'd be like 7 height. It wouldn't make sense. And also, I don't know how to say, but it wouldn't make sense.
And see, that's part of doing mathematics also, is making sure that it makes sense, reasoning the answer, making sure that it makes sense when you take a look at it the way it's written, correct?
Yes.
All right, well, Jonathan, thank you very much for that phone call. For phoning in today, you've got yourself 2 tickets to any athletic event at CSUB, courtesy of the CSUB Athletics Department. So thank you very much for that. All right. Oh, you got the right answer, too. All right, that means you get to go do some more work. Over to the board.
oh, okay.
All right, so here is another type of problem that you're going to be working on. So we'll take a look. This is number 3. We have 3x plus 2y is equal to negative 15. Then we have 2x is equal to negative 18. So what we need to do is we need to solve for x and for y. So you and Susie can work together. Why don't you let Susie know how you would like to start on this problem? And if you're stuck, that's why Susie's there.
Okay, well, I think I'm going to start solving for x.
Okay, in this one or that one?
Oh, wait. I already know what x is. 9.
Almost?
Negative 9.
Right, okay.
Because of the negative
So-
18. Because 2 times.
You know that this is kind of like being a detective. You use one clue to help you with the next one. So we know that x is negative 9
Which means,
from this.
yeah,
And so now can you figure out what the other is?
this would be negative 9.
So you can just rewrite it down below if you want, Christian, instead of
Here.
reaching up there if you want. You just
Okay.
rewrite it down below.
Or you can,
Okay.
so- okay.
If 3x equals negative 9, so 3 times negative 9,
Is,
negative 27.
right. do we move it up again? I forgot.
There we go.
Okay. So now, you've been solving equations, right?
Mm-hmm.
All right, so
Okay.
we're going to have you guys work on that, and we'll be back to check that out in just a moment.
Okay.
Hey, we're back here, a little math in the real world, because we want to know exactly what goes on in the vineyards that surround us here in Kern County. We want to know a little bit more about the details of it, and so my friends Jeff and Art are here today to tell us a little bit more about kind of what really happens in the fields to get those amazing pieces of fruit to the grocery store. Jeff has a little bit of some sizing instruments here that we talked about a little bit earlier, and Jeff, at my farm, boy, my grapes are so small. They're just tiny little peas. They taste really good, but they're really small. So there's some specific things we want to do here, right, guys, to make sure that the grapes not only look this amazing and taste this amazing, but grow to this size. So can you talk a little bit about how we size things and make grapes bigger?
Yeah, I'll touch a little bit about it. First of all, it comes down to, and Jeff can explain that a little bit, in a couple of seconds, but, jib,
Right.
size sprays, right, Jeff?
Yeah. Sure.
And but not just only size sprays, but also girdling, and I'll explain that a little bit right now, and also thinning.
Okay.
You don't want, and also the crop load. So you have a lot of factors that have an effect on the size of the berry, the size of the bunch.
Right. So
and
you
everything
thin the
comes
vines,
together.
but
yes.
then you thin the bunches. Talk about that real
Exactly.
quick.
So what we do is that, and Jeff will touch a little bit on that, Jeff, on thinning the bunches.
So there's a natural hormone called gibberellic acid.
Okay.
And so what we do at bloom time, we knock these flowers off. So imagine these are all flowers.
Okay.
And so maybe there's 300, I haven't done the counts, but for example, there may be 300 flowers on here. And we put the gibberellic acid on, and that takes off the flowers, it removes them. Okay? Your bunches are all tight because all the berries stuck.
Right.
Okay.
Right, yeah, I
so,
drew 300 berries.
Now
a whole
what
bunch.
happens? Common sense is if you remove berries, what happens to the berries? They get bigger, and so we have to create a space in here.
Okay.
So we do it naturally, enhancing it. Okay. Then that same gibberellic acid, you ready? It makes them bigger. Okay.
Wow.
And so what it does is it multiplies the cells. Okay.
Okay.
And when the berries get a little bit bigger, science is awesome, and it's
Yeah.
math. And so what we do is then we put on that, and the magical part is they're all different. And so some of it we are measuring as low as 3/4 of an ounce. So we have to use a syringe like a veterinarian does.
Yeah.
And we measure that out using a syringe, and we put that in 600 gallons. And that's so it's just a little bit.
Just
very,
a tiny bit.
yeah.
Yeah.
And then so some of it we go 3/4 of an ounce, some of it's an ounce,
Right.
some of it's an ounce and a half, and others we put on 5 or 6 ounces.
Wow.
And so each crop and variety is different. And so
Yeah.
Art's gonna have to talk about physically.
Okay. And physically, what we do to make these things bigger.
Exactly. So what we, like Jeff talked about the jib, coming in, we're doing a jib spray. As it is, you get natural shatter already, right, Jeff, on a bunch. Regular you get natural, but it's not going to be enough. So we come in, do some of that, shatter, with gibberellic acid, and then of course we'll do the sizing. But at the same time, the jib, it's not going to work all the time, especially on certain varieties. There are varieties that are very difficult to shatter, and there's other varieties that it's very easy.
Right.
That's where we come in. We bring people in as labor, and what we'll do is that either we'll tip the bunch or we'll work the bunch.
Okay,
And
so
for
instead of
example-
having a big, long bunch that
Exactly.
goes all the way down here, we
Yes.
tip off the end.
And this is a perfect example here of this bunch
Okay.
that was not tipped, and sometimes,
Oh,
there's
right.
so much fruit, the people will tend. And here's a very good example of a bunch not being tipped. And what do I mean by tipping? Is coming in and maybe we'll give the people a certain measurement.
Okay.
We'll give them either a clipper length, to make it easier for them, or
Right.
we'll give them, maybe 4 or 5 shoulders, and we'll tell the people to tip it there.
Mm-hmm.
Why? Because we see that the bunch is actually very tight, so we need to loosen it up a little bit
Yeah.
so we can get the size.
Right.
Because if not, we're all just hurting ourselves by leaving the whole bunch, like you see this one.
Sure.
You know.
Sure. And that makes it really hard to put in a bag too, right? I mean, that's
Exactly.
a really big bunch of grapes, which is wonderful to eat, but you got to get it to a customer.
And also in a red variety, you're also going to be fighting not only size but color.
right.
The more berries you have in a bunch, well, guess what? You're going to have
less red.
less red you're going to have. Exactly.
There you go. That's
yes,
right.
sir.
Yep.
And the other thing too that we do is that, so we'll come in here and we'll thin them, you know,
Yeah.
with our clippers. And then he touched a little bit about the sizing.
Right.
And then there's another way of
And
sizing.
so you can test how big they are and how small they
Exactly.
are and know when to cut them, right? So we want
Correct.
to know a little bit more about that. We'll talk about some packaging. We'll talk about sizing the berries. We'll talk about, there's so much to talk about here. It's wonderful. We're going to eat some grapes, but I know that there's some more math to do in the studio. When we come back, maybe we'll be done with one of these bunches for ourselves, but we'll learn a little bit more about how they package them. Back to the studio.
Always nice to visit with the Kern County Farm Bureau, and have to say that the grapes that are out there are delicious. So we've had some of those grapes. Anyway, we have Kristen in studio, a 6th grade student from Kristen McAuliffe Elementary School, and they were working on a problem before, and you solved for x, and you knew that x was -9. You then took that value and substituted it in to one of the other equations. So Kristen, explain what you did then.
So, after I found out that it was -9, x was, we timesed 3 by -9, which equals -27, and then we put down the rest of the problem, and we combined like terms, or no, we canceled out. So plus 27, which cancels it out, -27 plus 27 cancels out, and then we added it on this side, which equals 12. And so it would be 2y equals 12.
Now, before you keep going, why did you add 27 to the first side? Why do you even add 27?
To cancel it out, to get one number off the board.
Okay, because I know there are going to be some students watching that are seeing this for the first time going, so I can just take any number off the board I want? So why are you moving that number? Why the 27? Why don't you just get rid of the 2y?
Have you heard of isolate the variable?
Oh, yeah.
So, and this is the variable, okay? And you want to find out what y is, not what -27 plus 2y is.
Yeah.
And so you gradually get rid of things until it just says y.
So I know you knew what you were doing, but I wanted,
Yeah.
because there are students watching this for the first time going, well, why do we get rid of 27? Because you want to get the variable by itself.
Yeah.
Perfect, so keep going.
So once we brought down the 2y, and once we added the 27 onto -15, it was 2y equals +12. Well, 2 times 6 would equal +12, so y equals 6.
And by the way, you were right when you said combine like terms. -27 plus 27 are, they're like terms, and that's why they were able to cross out. Okay, that wasn't wrong.
All right, so now what we need to do is we need to figure out the proper way to write that. So we knew that x was -9 and y is equal to 6. So how are you going to write your final answer? Because you can write just simply x is equal to -9 and y is equal to 6, but you can just like that. And how would you write it as a pair?
As a pair.
Because I don't think you've seen this yet.
Okay, so have you graphed points yet?
Yes. Yes.
Okay, well, the first number is x, and the second number is y. Okay, so
Oh, would it be -9, 6?
Perfect.
excellent.
That's exactly it.
and
That's what
never
I wanted you
forget
to
the
do.
comma. That's excellent.
And for some great work, you've got yourself a meal courtesy of our friends at Broken Yoke. So congratulations on
yay.
that.
I love that place.
Lots of
Yeah,
great
I've
food
been
out there. All right. And you know what? We have one more opportunity. We'll be back right after this.
Hey, we're back here with a little math in the real world out here in the vineyards, which is a beautiful place to be on this gorgeous morning. We want to know a little bit more about how to make these grapes not only delicious, but really sized right. And in the last segment, we talked a little bit about trimming the bunches, right, to make sure that they have enough room to grow. We talked a little bit about gibberellic acid, making sure that the right nutrients are there to not only shatter, but to be able to make them grow bigger, right? And I know that there's 1 or 2 other methods that we can use to make grapes grow bigger. One of them is girdling, maybe a couple other things. Talk about those, Art. Tell us what else we can do to make these grapes nice and big.
Yeah, so another method that we use for sizing, and on certain varieties, not all varieties, of course. Some varieties don't react very good to a girdle. Some varieties do.
Right.
For example, just across the avenue from here, we had another variety that this block here we did not girdle. Another one we girdled, and we saw the difference. I mean,
okay.
and that has a very effect on it, not just far as quality, but also as packaging, you know, versus 1s, number 2s, and number 3s, you know, 1 being your top.
Okay.
What's the girdle?
Yeah, so
And
tell
what
us
are you
about the
talking
girdle.
But a little bit of girdle. So what we do here is girdle is we come in here with the knife, and unfortunately I don't have a knife to show you, but we'll come in and girdle the trunk. And
that means to
basically,
cut around the edge, right?
exactly. So a girdle is if you can imagine a knife, but you have two knives together. And what we do is that we just come in and girdle around the whole trunk. It's the bark, and what it does, Jeff. You can explain a little bit about that.
So in here, underneath this bark, is the cambium layer. And so you have the phloem, which takes the water, and the xylem. Xylem takes the water and goes up the tree, and that supports the water. That's the highway for the water.
Okay.
The phloem, it's his sister and brother. The phloem goes up and down. The xylem goes up, and the phloem goes both ways. So it takes the sugars both from the roots and to the trees, and transports back both ways.
Right.
So what we do is we want to shut off the phloem.
So that no sugars go back down.
That's right.
Yeah.
And then all the phloem, all the sugars up in the plant stay up there, and then we get this sizing of sugar.
Right.
And it's the trick is when we make this cut, and the width of it is not to kill the vine.
Sure, that's a really delicate process.
Yes,
So
and
that's
that's-
another labor part for you, right? You have to have some experts
Exactly.
not only trimming, but boy,
and
that's
these these are people that know, and these are people that have done it through years,
Right.
and they know how deep to go. And a very good example is that whenever they make the cut, if you see a little bit of that whiteness on it, you can tell that they're going a little too deep.
Okay.
And what we do is we'll have a supervisor come and check and just make sure that they don't go as deep, because they'll cut they'll end up killing the vine. It's just like us. If we cut our arm off, we get that main artery, we're going to bleed to death. Something
Sure.
similar to this,
Yeah.
where we can only make a very cut. If you cut here, it's not going to be as much, but if you go deeper, you can get an artery, you can bleed to death. Same kind of concept with this. You don't want to go too deep, because then you will kill that main source of water, and sugars moving up and down, and end up killing the vine.
Right, and that's a bad deal. Now, I want to make sure that we get to this, because Jeff, last time we talked a little bit about how students get involved in doing what you do, and you love your job. We know that part. You're not coming to work, you're coming to fun every day. Art, tell us a little bit about how students get involved in what you do. What kind of things did you take in school? How did you get involved in being in agriculture? Because it wasn't always your plan, right?
And it wasn't always my plan. I grew up in a farm and working out in the fields, but I never really thought that I was going to end up in agriculture.
Yeah.
The only thing that I do remember is when I would see PCAs like Jeff,
Yeah.
they would come out to the field and look, and I always wonder what they would be doing.
Sure.
And but of course I was in there picking apples, picking grapes, thinning, doing all that hard labor, but never really thought that I was going to get involved until finally I met a gentleman from Los Baños. He was a PCA, and I just started following him one day, and he was out checking traps for codling moth. Which is a calling moth, which is a worm for apples.
Okay.
And so I just kind of followed him, and then he goes, you know what, I'm going to give you a summer job. And my
Oh,
job
good deal.
was to go out there and check traps.
Yeah.
So I kind of got hooked on that.
And that
I
had
kinda
to take some math, right? You had to do some math out there. You had
I
to
had
count.
to do math. Yes, I had to take counts.
Lots
Very
of
important.
counts.
Counts are very important. Why? Because when the next cycle is.
Yeah.
And so that was very important for him, that I made sure that I got the right counts and give him that, so he knew when this next cycle went to spray for the next time.
Sure.
So
And you
that's
never
how I got
know.
involved.
Gosh, you never know where things are going to lead you, right? I mean,
Never.
heck, maybe I'll give up teaching someday and come be a farmer with you guys. Really appreciate your time today, guys. Learned a ton. We might even have to come back one more time, because we're just learning so much here about how things go on, what I call behind the scenes, not at the grocery store, but where we actually make things happen. I know there's some more problems to do, and there's some more grapes to eat out here, so we'll get back to the studio.
All right, thanks for that, Scott, and also thank you to the Kern County Farm Bureau. Christian, did you have fun today?
Yes.
I'm glad that you did. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.